This video is going to be for Design and Communication Graphics for PN 4025 for week 7. The topic we're going to be dealing with this week is going to be Conics, which is short for conic sections. Now, when dealing with conic sections, what we're really talking about is our 4 different types of conics here on the right hand side, where you can see circle, ellipse, parabola and a hyperbola. Now, the difference between these 4 different conic sections is the way in which the cutting plane is angled when cutting through this solid object, which is a cone. Now, for the circle, we're not going to be too bothered about that when traveling through this chapter. It's the simplest of the 4. We are going to be mainly concerned with our ellipse, our parabola and our hyperbola. Now, our circle, it's important to note that it is a cutting plane that is parallel with the base circle or perpendicular to the axis, the central axis of the cone itself. Now, for the first one that we're going to have a look at will be our ellipse, as you can see here, which has its cutting plane cutting through it at a certain angle, producing an ellipse. The same thing with our parabola, a different angle this time, producing our parabola. And thirdly, our third cone with a different angle again for our cutting plane, producing a hyperbola. Now, we'll go into detail in each one of these as we're traveling through our slides, and you'll be finding out the difference between each of them and why the different cutting angles are producing our hyperbola, our parabola and our ellipse. Now, firstly, we'll go into depth about our parabola. As you can see here, we have our 3-dimensional view again with our cutting plane, as well as that showing us where our cone used to be before the section was cut out of it. As well as that, we have our 2-dimensional drawing here, where we have our elevation, which is looking in at our cutting plane as an edge view. So as you can see here, when we take an auxiliary, or our first auxiliary, parallel with that cutting plane, as you can see here, we are then producing an auxiliary plan of our parabola. Now, it's important to note the different, key bits of terminology when dealing with a parabola. Now, the main bits of terminology are going to be similar across all the different conic sections, but some of them are obviously going to be located in different places. Now, as you can see here, these are the main bits of terminology when talking about a parabola. You can take note of it in your own time. If you like, you can take down a quick diagram and take down all the different key points. You'll notice throughout this and throughout the examples, as well as the drawings that you will be making, you will be taking note of these, identifying them and using this terminology to explain what you are doing. Especially when talking to the students themselves, it's very important you use the right terminology and consistently use it so that there is no confusion between the points and parts of the drawing that you are talking about. Now, it's important to take note here of this diagram. Now, the diagram on the left and the diagram on the right are linked. One's a 3-dimensional view and one's a 2-dimensional view. Now, as you can see here, you can imagine the colored part of this 2-dimensional drawing. Imagine if this is your elevation. And what you've identified here is all where our key bits of terminology, which you'll become very familiar with, are derived from. So you can see where our auxiliary is taken, which is parallel to this actual line here, which I suppose is our plane that we're looking across at. You'll identify where each bit of bits of terminology are derived from. As well as that, you can have a look at our 3-dimensional view here, which also identifies where our key bits of terminology are derived from. This is not very important for students to learn within a 2nd level classroom. Although some students might be inquisitive and want to know where each bit of the terminology are coming from, for example, the directrix, the vertex and the focus, it's important for you as an educator to have, I suppose, an understanding for where all the bits of terminology are actually coming from in relation to these drawings. So taking note of these diagrams and looking at yourself and breaking down the information as provided is very important. As well as that, there is 3 main methods of constructing a parabola, as you can see here. Most of you will be familiar with the method on the left hand side here. Now, it's hard to see, but what I would like you to do is, when learning these 3 different methods, is to actually open up the graphics book, preferably David Anderson's, because he speaks about each 3 different methods here. But I'm pretty sure, depending, or whatever graphics book that you'll open up, a Leaving Cert graphics book will have multiple methods in it on how to construct the parabola itself. It's important to take note of the 3 different methods. The reason for it and have an understanding how to draw them is because depending on how the question is asked and the information you're provided, it depends on what method that you will use to construct it. So for any one of these methods, I suggest that you will open up the David Anderson's book or have a look online and see how each one of the methods are constructed. Now I will be providing an example for each one of the conics, which will walk through a method of constructing it, depending on how the question is asking. But it is important for you to understand how the three of them work. They are fairly simple methods, but it will take a few minutes for you to look at it and nearly memorize how the construction is carried out. I find the best way to remember is by doing it, so I might carry out each of the constructions 2 or 3 times at the start just to remember how the construction works and to have it fresh in my head. This is the first example construction which travels through a question that's talking about parabola. I break down the question, talk about why I pick the methods I do to construct it, depending on how the question was asked. Here is the solution. As you can see there, it's actually very simple. There's not a lot of work related to completing a lot of the questions that you were provided for conics. The hardest thing about it is getting to know the constructions and getting to know the rules that you have to follow when constructing different parts. Now a lot of the information, well, nearly all the information you'll need to know will be within the graphics book. It will just be for you to break down that information and then apply it to the questions that are being asked. Now we'll have a look at the ellipse. As you can see, we have another cutting plane here which is traveling through the ellipse, and this is producing our elliptical shape here in our auxiliary plan when we're looking at it as an edge view in our elevation and then looking at it as a true shape here in our auxiliary. As well as that, you can see all the different generators and you can link that back to your 3-dimensional drawing over here. Again, we have our focal spheres. Take note of these drawings, have a look at them. I've seen students in the past make SolidWorks models to explain where all the bits of information are. If you would like to do that, you're more than welcome to. It's probably unnecessary. If you'd like to take a sketch of how it works, that would probably be more important and cover the points just as well. I know the 3-dimensional view here looks fairly complicated. I would suggest that you would mainly look at the 2-dimensional view over here and then link that information back to the 3-dimensional view. Again, we have our key bits of terminology, which are all important. A lot of them are familiar to you after going through our parabolas key terminology. A lot of them will cross over between the two, or between the three. Again, we have our 3 different methods for constructing. You'll notice that 2 of the methods are similar, which are rectangular method and our eccentricity method. For anyone who has carried out the junior cycle, you will be very familiar with the concentric circle method of completing an ellipse. This more than likely will not be used in our 3rd level drawings just because it's very simple. If so, there will be a twist to it that you will have to use the construction as shown here somewhat backwards to construct the ellipse. But I won't worry about that till you get a question. As long as you have a good idea of how the construction works, you'll be able to work backwards from that. Again, here we have our example construction. And now moving on to our hyperbola. As you can see here, we have our cutting plane, which is vertical to our base circle, providing our hyperbola, as you can see here in our end view, which is looking basically perpendicular at the plane itself, showing us a true shape. As you can see, our elevation again is looking at that cutting plane as an edge view. For this one, our focal spheres diagram and showing our terminology is very, very simple compared to the other 2. Again, we have our key bits of terminology, which you should take note of. A lot of the key bits of terminology not mentioned here are previously mentioned in the other 2 constructions, and you'll note that things like the focus and vertices are still present here. Again, we have 3 different methods. You'll notice that 2 of them again are similar, our eccentricity method and our rectangular method. And after that, then you have your 2 activities for this week's lab. Both of them don't require much work to complete, but does require an understanding of your conic sections to complete. Now, one thing that I failed to mention as I was traveling through this, it's important to know for the eccentricity of each one of the conics. So if you're dealing with a hyperbola, you're dealing with eccentricity that is larger than 1. If you're dealing with an ellipse, you're dealing with an eccentricity that is less than 1. And if you're dealing with a parabola, you're dealing with an eccentricity that is 1. After you have that completed, it's important for you to go through this checklist, ensure that you have everything completed for this week's lab and tutorial, and submit it for week 7 to ensure that you have all your coursework in on time.